So for section 5, we're looking at more properties of exponents. We're bringing in negative exponents and then a little bit with fractions. So if we start with just a to the negative 1, we can make that 1 over a to the first. Okay, whenever we have a negative exponent, again.
Hey, never mind, it broke. Oh, it's fixed.
Okay, whenever you have a negative exponent, you move it across the fraction bar, you make it a reciprocal of it, it makes it into a positive exponent. So if I had a to the negative b, I could make this into 1 over a to b. It's now a positive exponent. It doesn't matter what the exponent is. If I move it across the fraction, it makes it positive. Now we don't want to think that anytime it's negative, it's automatically in the denominator. Because if we had 1 over a to the negative 1, we can move that up and it just becomes a to the first. And then continue that idea, 1 over a to the negative b would just become a to the b. Now, anytime you have a negative exponent, and if you look at the work, the problems that you're assigned, it says write it as positive exponents only. You're going to move it across the fraction, take the reciprocal of it to make it positive. So we'll see that in different forms. The other thing we're going to see now is if we have a to the b over a to c with division. When we had multiplication, them side by side, something like ab times ac, we would add b plus c. That was from last week, early last week. Here we're going to subtract, so it becomes a to b minus c. Now, we can get that because if I had something up here, this multiplication, if this c was negative to start with, that means it would have been underneath the fraction, and I would have had like a to b times a fraction, which would have worked out the same way. Now, we don't always have to use the subtraction. If I had something like, let's move that down, x to the 4th over x to the 6th. Does the top or bottom have more x's?
Bottom.
How many more?
2 more.
2. So you can just write that as 1 over x squared. And that can be just writing out, expanding it all and saying, all right, 4 on top, 6 on bottom, reduce out 4 sets of them, you're left with 2 on the bottom. I'm not sitting there going 4 minus 6 to figure out where it goes. Subtraction is the rule, but we can kind of just use our reducing idea to help with that. Another thing to add, if I have a over b to the x, we're going to distribute out that exponent. It's going to be a to the x over b to the x, making sure you distribute it to all terms. And that would be up the top, even if I had like something like 2x. Make sure I distribute that in to each term. Now, other than those, we're not really going to have, we're going to bring in some other rules we've already seen, like exponents to exponents last week. And kind of really the theme here is looking at fractions, simplifying down. No radicals, no simplified radical form in this. It's mainly fractions today. So let's look through some examples. We'll work across some rows here. So it would be 2 to the negative 3 is going to become what? Multiplied out. Yeah, 1 over 8, because that is 1 over 2 to the 3rd, makes it positive, and then 2 to the 3rd is 8. 7 to the negative 2. 1 over 49. 8 to the negative 2. 1 over 64. Now, next down I have 3x to the negative 2. And then I have, and that's in the quantity, has a negative 2 exponent. And then to the right of that, I have 3 and then x to the negative 2. Very different, and a lot of this is that distributing out the exponent. For the one on the left, the negative 2 needs to go to both terms. So it's going to be 3 to the negative 2, x to the negative 2. Now we can't leave them as negative exponents, so they go underneath the fraction, and I get 1 over 9x squared. Moving them across the fraction makes the exponent positive, and then simplify from there. Now, 3x to the negative 2, since the negative 2 exponent does not apply to the 3, that stays as it is, and then the denominator is now an x squared by moving that underneath. And that's one, just pay attention to when you have the parentheses involved. Next, we go to x over 3 to the third. Distribute it out. I get x to the third over 3 to the third. What is 3 to the third?
27.
Good. Next to that, I've now brought in a 2. Make sure you don't write it as 2x to the third on top. What should it be in the numerator? 8. 8x cubed over 27. 8 and 27 do not reduce. 8 has factors of 2. 27 has factors of 3. Okay, write it as that. Now, speaking of factoring, if I look down at our last one, 4x and that quantity squared over 12. You do not reduce first. Think back to orders of operations. You did parentheses and exponents first. Take care of the exponents. We want to distribute them out. I'm going to get 16x squared on top, 12 on the bottom. Now that that's distributed out, I can reduce, and what's it going to be? What's the numerator? Yeah, 4x squared over 3. You'll find a lot of the mistakes that you may see, it's going to be order of operations. Reducing before you can, even like in adding, just kind of add incorrectly. Pay attention to those basics. The rules we pick up. What's nice about this, the distributing out the exponents, the negative exponents, through all of this, it's always the same. It's the moving the little pieces around we've got to be careful with. All right, let's add more to these. I'll make the numbers larger here. Isn't it nice?
You should just hand us tablets.
So we have 4x quantity squared over 9x squared, that quantity squared. Distribute out, what is our numerator? What's the numerator going to be? 16x squared. Denominator? Okay, 1681, can I reduce? No? But I can reduce the x's. Which part has more x's? How many more?
2 more.
So it'd be 16 over 81 x squared. All right. To the right of that. Numerator is what? Okay, 4x to the what?
6.
Yeah, and that's going to be the x to the third squared. You have 2 sets of 3, so we multiply. 3 times 2 gives us 6. Denominator, I got that negative 4, which I'll take care of in a minute. X squared. I look at that and I think, I want to move the y to the negative 2 up to make it positive. I don't want to add more steps than I need to. If it's a positive exponent, it'll reduce, it'll clean up nicely. That comes up. What's nice about that is that's the only y in the problem, so it actually took care of itself. So, in our answer, 4 over negative 4 is a negative 1, so it's going to have a negative. Where are the x's left? Top? How many?
4.
Yep. And then y, we had 2. So this actually is just going to become negative x to the fourth y squared. It's the same thing, because it's 4 over negative 4 is negative 1. So it just means the whole thing's negative. We don't need to move the negative down.
I thought the diffusion by negative 4 equals negative 1.
It does.
Which would be on the bottom instead of the top.
It does.
That's the same thing.
That's the same thing. Because the denominator is 1, you put the negative out in front. It's the same. Okay. Next one with the 4xy over 3x cubed and all of that to the negative 2. We could distribute it out. It would work. I don't like to add extra negatives if I don't need to. How could I make that negative 2 into a positive? Let's do this. If I then made it, how about 4xy to the negative 2 and 3x cubed to the negative 2? I can do that. I can break it into the separate exponents. How do I get rid of the negatives? Yeah, I could flip both of them. So I could take the 4xy, move it underneath. It's still squared, but now it's a positive 2. Take the 3x cubed, move that up, and now that's a positive 2. So that's going to allow us to kind of get rid of the negatives and go forward and simplify. Now, if you distributed it out, that's fine. It's not that it's going to be wrong, but it might be a little cleaner this way. So with that, in that case, what is my numerator?
9x over 6.
9x to the what?
9x is 16.
Good. Over?
16 x squared and y squared.
Do 9 and 16 reduce?
Yeah. Wait, no.
No. Both perfect squares, they don't reduce though. So we're going to have 9x to the fourth over 16y squared. All right. I talked too long. Now it's your turn. Hey, we have these two problems. I think you should do them.
Thank you.
So the first thing we should probably look at is getting rid of the parentheses on the first one. So I'm going to go 25a squared b squared times 3a cubed b. Denominator, I have 3a to the negative 1. You want to leave that a to the negative 1 down there, or you want to move it up now? Yeah, leave it down there. Now, what is negative b to the third squared going to be? Positive or negative?
Positive.
Yeah, we're squaring a negative. You square a negative, becomes positive. So that becomes b to the sixth. So with that, with the 25 and 3 and then the 3 on the bottom, and that's going to reduce, I'm just going to have 25 left over on top. Agree with that?
Yes.
Okay. I have 5 a's on the top, but a negative a on the bottom. What's that going to result in being?
A on the top. Adding a negative.
Add 1 up, so it's going to be a to the sixth. Okay? I have 3 b's on top, 6 on bottom.
You then have 3 cubed on the bottom.
Yep. So 25, a to the sixth, b to the third. Okay? You there? Questions on that one? All right, next one. So I have x to the negative 3 on top, 4 on the bottom. If I take the negative 3, move it down, I have x to the 7th on the bottom. Y to the negative 4, y to the negative 2. I flip them. It's now y squared over y to the 4th, which means how many y's end up where?
On the bottom.
And z. What happens?
Z
Z to the 4th on the bottom. So it's 4 over x to the 7th, y squared, z to the 4th. All positive exponents. We're good there. That's how you write your answer. If you moved some up and you made it like negative 3 minus 4 for the x's, you have to make sure you do make it positive by moving it across the fraction. Positive exponent results.
How do you get positive for y?
If I had these two and flipped them,
It'd be 2.
it'd be 2 over 4. So I'd have 2 extra on the bottom. Or negative 4 minus negative 2 is negative 2. Move the negative. All right. 2 more. Then we're done.
But what if we understand it completely?
Good.
Is that a 1? That's a 1.
So we're looking one.
Hey, I don't look at your paper and criticize your ones.
It's just a
You
line.
look at his paper.
Yeah, I just do a line.
So now it's 4xy cubed and 3x squared y negative 3z 4th squared. Okay? Now they're in the right place. I've gotten rid of that negative 2. If you wanted to distribute it out, you could. But now they're kind of all together. I can distribute out the 3 and the 2 respectively, then start piecing it together. So I got 4 to the 3rd, x to the 3rd, y to the 9th. 3 squared is 9. X to the 4th, y to the negative 6, z to the 8th. All right, 4 to the 3rd is 64. 64 times 9 is,
576.
thank you. Okay, I trust you can multiply. You can find that. Now, what I'm more concerned with are the x, y, and z's going to go in the right spot. So, where's the x going to go and how many?
There's 7 on the bottom.
7 on the bottom? Okay. How about y?
6 on top, so there's 3 on the bottom.
3 on the bottom?
No, it's 15.
3 on the bottom.
Why is it 3 on the bottom?
Because there's a negative 6.
Okay.
It goes up.
Wait, that's a negative? Oh, wow.
6 goes up.
Oh, yeah, it's okay.
Why?
Are we okay with this first being negative 6?
Yeah.
I moved it down, then I made it negative 6, right? Okay. Now, you could move it up, so then you have y to the 6th over y to the 9th, so you're left with y to the 3rd on the bottom. Or, they're like bases, you add them. 9 minus 6 is 3, stays down here.
Ha.
So, however steps you get to it, as long as we end up with y to the 3rd on bottom, we're okay. And then z, 8th, stays down there. Now, only when it's negative and stuck in the denominator do we have to move it. If we simplify it like x, y, and z here, and they're positive, they're fine down there. It's if I got a result that was negative, then we'd want to move it up.